Hello, good morning everyone. I'm Loren Abellana from Group 12, and today we will be discussing all about groundwater. So before we dive into the topics under groundwater, is ila-ilaon sa nato no ug unsa na siya. So groundwater is an important natural resource that we have. Groundwater is the water found underground in the cracks and spaces in soil, sand, and rock. It is stored in and moves slowly through geologic formations of soil, sand, and rocks called aquifers. So the beautiful caves, caverns, and cave deposits are produced by groundwater movement, which I will tackle later on. So although groundwater constitutes only 0.63% of the world's water, it is nonetheless a significant source of fresh water for agricultural, industrial, and domestic use. So inaana ka importante ang groundwater no, kay kitang tanan gagamit ana just like sa sinaunang panahon, groundwater are used as a drinking water. So next is the hydrologic cycle. So the hydrologic cycle involves the continuous circulation of water in the Earth atmosphere system. At its core, the water cycle is the motion of the water from the ground to the atmosphere and back again. So, unsa day ang connection between groundwater and hydrologic cycle? Like any other water in the hydrologic cycle, the ultimate source of groundwater is the oceans. However, its more immediate source is the precipitation that infiltrates the ground and seeps down through the voids in soil, sediment, and rocks. Groundwater may also come from water infiltrating from streams, lakes, swamps, artificial recharge ponds, and water treatment systems. So next is the porosity and permeability. Porosity and permeability are important physical properties of earth materials and are largely responsible for the amount, availability, and movement of groundwater. So water soaks in the ground because soil, sediment, and rock have open spaces or pores. Porosity is the percentage of a material's total volume that is pore space. So porosity most often consists of the spaces between particles in soil, sediment, and sedimentary rocks. But other types of porosity include cracks, fractures, faults, and vesicles in volcanic rocks. So just like in the picture at the left side, that is an illustration of a porosity, so kanang mga spaces, mao na siya. Porosity determines the amount of groundwater that earth materials can hold, but it does not guarantee that the water can be easily extracted. So in addition to being porous, earth materials must have the capacity to transmit fluids, a property known as permeability. Permeability is a measure of the ease of the flow of a fluid through a porous solid. A rock may be extremely porous, but if the pores are not connected, it will have no permeability. And to clearly understand about porosity, here are some examples of different materials with their porosity values. So on the left side is the diagram of a porosity values for different materials. So just like soil, iyang porosity percentage is 55. Then ang gravel is 20 to 40. Then sand is 25 to 50, silt is 35 to 50, clay is 50 to 70, and so on. So on the right side naman is naay 4 kabuok illustration. So sa letter A, mauna siya ang example of well-sorted sedimentary rock nga high og porosity. So naay mga spaces no. So sa B side is mao na ang example of a poorly sorted one that has a lower porosity. Makita man siguro ang difference between the two, no? Then sa C, insoluble rocks such as limestone, porosity can be increased by solution. So, kana nga kuan is nag-use na siya og chemical para mutaas ang iyahang porosity. So, inana ang itsura up close. Lastly, the letter D is crystalline metamorphic and igneous rock can be rendered porous by fracturing or i-break gani. So, mao na siyang liki-liki. So, ang permeability di is dependent not only on porosity but also on the size of the pores or fractures and their intersections. So, for example, Deposits of silt or clay are typically more porous than sand or gravel, but they have low permeability because the pores between the particles are very small and molecular attraction between the particles and water is great, thereby preventing movement of the water. In contrast, the pore space between grains in sandstone and conglomerate are much larger and molecular attraction on the water is therefore low. On to the next slide is the types of geological formations of groundwater. So there are four types. The first one is the aquifer, the second one is the aquitard, and the third one is the aquicolud, and lastly the aquifuge. So first one is the aquifer. An aquifer is a saturated formation of the earth. It not only stores the water but also yields it in adequate quantity. Aquifers are highly permeable formations and hence they are considered as main sources of groundwater applications. So there are two types of aquifer, the unconfined aquifer and confined aquifer. An unconfined aquifer is an aquifer which has free water surface, which means the water table exists for this type of aquifer. This is also called as water table aquifer or free aquifer or phreatic aquifer. Unconfined aquifers are recharged by the infiltration of precipitation from the ground surface. So, second is the confined aquifer. A confined aquifer is an aquifer confined between two impermeable beds such as aquifuge, aquiclude, and etc. The water in the confined aquifer will be under greater pressure, which is greater than atmospheric pressure. The recharge of confined aquifer occurs at a place where it exposes to the ground surface. So next slide is an illustration where you can see the unconfined and confined aquifer. So kanang blue part dira which holds the water is the aquifers. Next one is the aquitard. An aquitard is also a saturated formation. It permits the water through it but does not yield water in sufficient quantity as much as aquifer does. It is because of their partly permeable nature. But however, if there is an aquifer under the aquitard, then the water from aquitard may seep into the aquifer. As you can see on the illustration on the left side, the aquitard is placed between the unconfined aquifer and confined aquifer. Next one is the aquiclude. An aquiclude is a geological formation which is impermeable to the flow of water. It contains a large amount of water in it, but it does not permit water through it and also does not yield water. It is because of its high porosity. Clay is an example of aquiclude. So next is the aquifuge. Aquifuge is a impermeable geological formation which is neither porous nor permeable, which means it cannot store water in it and at the same time it cannot permit water through it. Compact rock is an example of aquifuge. So mao ni siya ang whole illustration which is makita ninyo ang aquiclude o aquifuge. So naday tayo two soil layers on Earth's surface. So the first one is the zone of aeration. The zone of aeration is the region that lies between the Earth's surface and the water table. The main components of zone aeration are soil and rocks. The zone of aeration is also known as the unsaturated zone. The pores in this region are usually filled with air and water. Aeration takes place when air and water come into close contact. The presence of air and water gives rise to the formation of soil moisture. Air indicates the presence of oxygen, which influences the rate of corrosion of metal objects buried under the ground. So the second soil layer is the zone of saturation. The zone of saturation is the ground region immediately below the water table. It is also known as the phreatic zone. In this region, the pores are saturated with water but also composed of soil and rocks. The zone of saturation is less corrosive and the moisture content in this region is at one extreme. Therefore, maximum corrosion occurs in the middle of two extremes. The zone of saturation is usually found between a few feet and thousands of feet below the Earth's surface. Most drinking water is held in this region in the presence of rivers, springs, and wells. So, mao ni siya ang illustration of zone of aeration and saturation. So, unlike the aeration zone, all pores in the saturation zone are filled with water. And next is the water table. The water table is the boundary between the unsaturated zone and the saturated zone underground. Below the water table, groundwater fills any spaces between sediments and within rock. As you can see sa picture, the line between the zone of aeration and zone of saturation is the water table. Next slide is the groundwater movement. So gravity provides the energy for the downward movement of groundwater. Eventually, it emerges back to the land surface, into rivers, and into oceans to keep the water cycle going. In this illustration, water entering the ground moves through the zone of aeration to the zone of saturation. When water reaches the water table, it continues to move through the zone of saturation from areas where the water table is high towards the area where it is lower, such as streams, lakes, or swamps. Only some of the water follows the direct route along the slope of the water table. Most of it takes longer curving paths down and then enters a stream, lake, or swamps from below, because it moves from the area of high pressure towards area of lower pressure within the saturated zone. Next is the springs, water wells, and artesian systems. So what is spring? A spring is a natural exit point at which groundwater emerges out of the aquifer and flows into the top of Earth's crust to become surface water. It is a component of the hydrosphere as well as a part of the water cycle. Springs have long been important for humans as a source of fresh water, especially in arid regions which have relatively little annual rainfall. So, an example of a spring is the Mammoth Cave area in Kentucky. Is underlain by fractured limestones whose fractures have been enlarged into caves by solution activity. In this geologic environment, springs occur where the fractures and caves intersect the ground surface, allowing groundwater to exit onto the surface. But springs can also develop wherever a perched water table. So, paryaning na sa picture, kanang na perched water table diha nga label. So, mao din na siya ang a local amplitude present within a larger aquifer, such as a lens of shale within sandstone that intersects the surface. So, as water migrates through the zone of aeration, it is stopped by the local aquiclude, and a localized zone of saturation perched above the main water table forms. Water moving laterally along the perched water table may intersect the surface to produce a spring. So in short, if naa ganing perched water table, possible na siya nga mahimong spring. The next one is the water wells. Water wells are openings made by digging or drilling down into the zone of saturation. Once the zone of saturation has been penetrated, water percolates in the well, filling it to the level of the water table. A few wells are free-flowing. For most, however, the water must be brought to the surface by pumping. So, mo na siya ang katong natay tabay o nasad tay puso. So, aside sa katong tabay, naatay three kinds or three ways of pump. Naatay hand pump, electric pump, and windmill. So, ang hand pump, dili na siya bag-o na to kay kato nang sinauna nga manumano ra ang pagpump kani sa tubig. So, puso. Then, ang electric pump is nag-use lang siya og electricity para dili na siya hasol o kapoy magmanumano. So, the third one is the windmill. Instead of a handle attached to a rod with a piston, the rotating blades catch the wind, which turns the rod that is attached to a hub's assembly that converts the rotary motion to an up and down motion. and water is brought to the surface in the same manner as a suction hand pump and is pushed into a storage tank. So pareha lang siya o kanang way sa hand pump o electric pump, pero ang iyahang gamit lang is wind lang siya. The next one is the cone of depression. A cone of depression forms whenever water is withdrawn from a well. If water is withdrawn faster than it can be replenished, the cone of depression will grow in depth and circumference, lowering the water table in the area and causing nearby shallow wells to go dry. So in the illustration, so kanang V dira is the cone of depression. So ang giingon ato is if mas paspas gani ang pagkuha og tubig kesa sa pagbalik sa tubig or pag-replenish sa water, is mo form ni ang cone of depression, which will cause nga ang mga nearby nga wells ana nga area ug asa nagkuha og paspas nga tubig kay mo dry out, so mawad-an og tubig. Next slide is the artesian systems, a groundwater condition formed by water-bearing rocks, aquifers, in which the water is confined above and below by impermeable beds. Artesian systems are named after the province of Artois in France, where artesian wells were first observed. So, mao ni siya ang example of illustration sa artesian system na ay flowing o non-flowing artesian systems. How artesian systems are developed? So naay tulo ka buok. So the first one is an aquifer is confined above and below by aquicludes. The second one is the rock sequence is usually tilted to build up hydrostatic pressure. And the third and the last one, the aquifer is exposed at the surface, thus enabling it to be recharged.
Groundwater erosion and deposition. Groundwater erosion is the opposite of deposition of geological process in which earthen materials are deposited or built up on a landform. Most erosion performed by liquid water, wind, or ice, usually formed in the glacier. If the wind is dusty or the water in glacier ice is muddy, erosion is taking place. So, ang erosion dye is a natural happening which performed by the liquid water, wind, or ice. Deposition. Deposition, by definition in chemistry, refers to the phase of transition in which matter transition directly from a gaseous state into a solid state without passing through an intermediate liquid phase. Deposition is the most opposite sublimation, a phase of transition in which liquid transition directly into gas. How karst topography form? Karst topography form is formed by the dissolution of the bedrock by water has picked up the carbon dioxide from the atmosphere and ground to form carbonic acid. The process is called chemical weathering. The landform result mostly from the chemical weathering of the host rock and the progressive integration of the subsurface cavities. Explain the formation of the caves. Speleogenesis, the form of the development of cave is known as speleogenesis. It can occur over the course of a million years. Caves are arranged widely sized and are formed by the various geological processes. This may involve the combination of the chemical processes, erosion by water, tectonic form, and microorganism pressure and atmospheric influences. List and define the major depositional features found in the cave. Depositional materials and features. There are three broad categories of the sedimental materials found in a cave. Clastic sedimental carried by the streams and infiltrated form the surface block slabs fragments of the breakdown derived from the local bedrock. Chemical sediment deposited in the cave by perlocating water. Distribution of the major limestone karst areas of the world. As you can see in the picture, na din na ang mga locate sa mga limestone all over the world. Why karst topography typically restricted to a region with humid and temperature climates? Karst is a topography formed by the dissolution of soluble carbonate rock such as limestone, dolomite, and gypsum. It characterizes the feature of the bulges above the drainage system with sinkholes and caves underground. It is also known to documented more weathering resistant rock such as quartzite even given the right condition. Sinkhole. A sinkhole is a depression or hole in the ground caused by some form of the collapse of the surface layer. The term is sometimes used to refer to dolline enclosed the depression of the locally also known vortices and sinkholes, an opening where the surface water entered the underground passage known as punor, swallow's hole, or the swallet. A cenote is the type of sinkhole exposed underground underneath. Sink and stream sink are more general terms that cite drain surface water, possibly infiltration into sedimental crumbled rock. Solution Valley, the the collapse of a cavern over the large areas creates a featured referred to as Solution Valley or basin. Sometimes refers to as Carp's Gulf, which is formed by the earth resembles a huge sinkhole. This depression may reach hundreds of meters across the contain numerous smaller locally sinkholes. Caves. A cave or a cavern is natural void into ground, specifically a space large enough of human into enter. Caves often formed by the weathering of the rocks often extended deep underground. The word cave refers to smaller openings such as sea caves, rocks, shelters, and grottos that extend a relatively short distance into the rock, and they called exogenous caves which extend further underground than the opening is wide are called Indian cave. Cave deposit. Cave deposit, also known as Palladium, any of the crystalline deposit by the form of the solution cave. After the creation of the cave itself, this deposition are generally composed of calcium carbonate dissolved from the surrounding limestone by underground. Cave formation. Caves are formed by the solution of the limestone. Rainwater picks up the water dioxide from the air and percolates through the soil, which turn into weak acid. This slowly dissolves out the limestone along the joint bedding planes, fractures some which become enlarged enough to form caves. Stalactites. Stalactites are cycled shaped structure hanging from the cave ceiling that form as a result of the precipitation from dripping water. As additional calcite is deposited, an upward growing projection called stalagmite. If the stalactites and stalagmites meet, they form a column. Ground seeping formed a crack in a cave ceiling may form a vertical sheet of rocks called a drip curtain, and water flowing across the cave. Across the cave may produce a tavern terraces. And thank you.
Good morning everyone, I'm Perez, Jeven, and I will discuss the modification of the groundwater system and its effect. Let us first define groundwater. Groundwater is an underground water stored in the pore spaces of soil, sediment, and rocks. Approximately 20% of all water used in the United States is groundwater. This percentage is rapidly increasing, and unless this resource is used more wisely, sufficient amount of clean groundwater will not be available in the future. So dapat gamito na to ang clean groundwater sa saktong butang kay para dili ta mahutdan in the near future ug dili ta magkalisod. There are also four modification of the groundwater system that has many consequences. First, lowering the water table. Second, saltwater incursion. Third, the subsidence. And lastly, the groundwater contamination. Let's start in the first modification of the groundwater system is the lowering the water table. Withdrawing groundwater at a significantly greater rate that it is replaced by either natural or artificial recharge can have serious effects. For example, the High Plains Aquifer, also referred as the Abellana Aquifer, is one of the most important aquifers in the United States. It underlies more than 450,000 square kilometers, including most of the Nebraska, large parts of Colorado and Kansas, portions of South Dakota, Wyoming, and New Mexico, as well as the Panhandle regions of Oklahoma and Texas. A study released in 2017 by the United States Geological Survey showed a 9% overall decline in recoverable water in storage from pre-development or generally before 1950 to 2015. It must be noted, however, that much of the High Plains Aquifer water infiltrated during the wetter glacial climates more than 10,000 years ago. Consequently, most of the water being pumped in fossil water that is not being replenished at anywhere near the same rate as when it formed during the Pleistocene epoch. Most users of the aquifer realize that they cannot continue to withdraw the quantities of groundwater that they have in the past, and thus, turning to greater conservation, monitoring of the aquifer, and using new technologies to try to better balance withdrawal with recharge rates. Let's proceed to the second modification of the groundwater system, which is the saltwater incursion. Let us first define the saltwater incursion. As sea levels rise along the coast, saltwater can move onto the land, known as saltwater incursion. This occurs when storm surge or high tides overtop areas low in elevation. It also occurs when saltwater infiltrates freshwater aquifers and raises the groundwater table below the soil surface. The excessive pumping of groundwater in coastal areas has resulted also in saltwater incursion, which has become a major problem in many rapidly growing coastal communities where greater demand for groundwater creates an even greater imbalance between withdrawal and recharge. Along coastlines where permeable rocks or sediments are in contact with the ocean, the fresh groundwater, being less dense than seawater, forms a lens-shaped body above the underlying saltwater. That's what you see in figure A. Because fresh water is not as dense as saltwater, it forms a lens-shaped body above the underlying saltwater. The weight of the fresh water exerts pressure on the underlying saltwater. As long as rates of recharge equal rates of withdrawal, the contact between fresh groundwater and the seawater remains the same. If excessive pumping occurs, a cone of depression develops in the fresh groundwater and a cone of ascension forms in the underlying salty groundwater, which may result in saltwater contamination of the well, and that's in the figure B. When this occurs, wells become contaminated with salt water and remain contaminated until recharge by fresh water restores the former level of the fresh groundwater water table. To counteract the effects of saltwater incursion, recharge wells are often drilled to pump water back into the groundwater system. And that's in the figure C. Pumping water back in the groundwater system through recharge wells can help lower the interface between the fresh groundwater and the salty groundwater and reduce saltwater incursion. The next modification is the subsidence. Subsidence is the sinking of the ground because of underground material movement is most often caused by the removal of water, oil, natural gas, or mineral resources out of the ground by pumping, fracking, or mining activities. As excessive amount of groundwater are withdrawn from poorly consolidated sediments and sedimentary rocks, the water pressure between grains is reduced, and the weight of the overlying materials causes the grains to pack more closely together, resulting in the subsidence of the ground. So, ang subsidence di ay kay kanaganing magsigi kag kuha og water sa ilawom sa imong gitukuran, mao na ang makakos nga mo tilt or mahiwi ang imong building nga gitukuran kay dili man level ilang compact sa ilawom, so mao na mahiwi. The San Joaquin Valley kay example ni siya sa subsidence. Ang kanidi ay is a major agricultural region that relies largely on groundwater for irrigation. Since the 1920s, excessive groundwater withdrawals in parts of the valley for irrigation have caused subsidence of nearly 9 meters. Ang kaning date nga naa sa poll ani kay mao ni siya ang amount nga nag-illustrate sa San Joaquin Valley. Tungod sa sigig kuha sa groundwater kay ang kaning San Joaquin Valley kay nag-cause siya og na-subside siya og nearly 9 meter between 1925 and 1977. Looking elsewhere in the world, the Leaning Tower of Pisa in Italy is also an example of a subsidence because it is partly a result of groundwater withdrawal. It started tilting after construction began in 1173 because of differential compaction of the foundation. So mao na katong dili gani level imong compaction or foundation sa ubos, mao na makakos sa tilt sa imong gitukod nga building or balay. Pag 1960s, ang kaning city of Pisa kay sige withdraw og dako nga amount of groundwater, mao na nagsige gihapon siya clean, pero nagkadugay kay nagstrikto sila og control sa groundwater withdrawal and nagsige sila stabilize sa foundation and sige renovate para mo reduce ang amount nga mo subside ang kaning building. A spectacular example of continuing subsidence is taking place in Mexico City. Ang kaning subsidence in Mexico City kay built on a former lake bed of the fine grain deposits. Excessive withdrawal of groundwater also from beneath Mexico City has resulted in subsident and uneven settlings of buildings. So maura gihapon ang rason magsige kuha og groundwater niya mapush og maayo sa ubos nya dili gihapon mag-level, so mao na ang result sa tilting ani nga building. Long Beach, California is an example of the extraction of oil kay pwede gihapon na siya subsidence. Ang kaning Long Beach, California kay ni subsided siya og 9 meter as a result of many decades of oil production. Let's proceed to the last modification of groundwater system is the groundwater contamination. It is a major problem facing our society is the safe disposal of the numerous pollutant byproducts of an industrialized economy. We are becoming increasingly aware that streams, lakes, and ocean are not unlimited reservoir for waste and that we must find new, safe ways to dispose of pollutants. The most common sources of groundwater contamination are sewage, landfills, toxic waste disposal sites, and agriculture. Once pollutants get into the groundwater system, They spread wherever groundwater travels, which can make their containment difficult. Furthermore, because groundwater moves so slowly, it takes a long time to cleanse a groundwater reservoir once it has become contaminated. In many areas, septic tanks are the most common way of disposing of sewage. A septic tank slowly releases sewage into the ground where it is decomposed by oxidation and microorganisms and filtered by the sediments as it percolates through the zone of erosion. Landfills also are potential sources of groundwater contamination. Not only does liquid waste seep into the ground, but rainwater also carries dissolved chemicals and other pollutants down into the groundwater reservoir. Toxic waste sites, where dangerous chemicals are either buried or pumped underground, are on increasing source of groundwater contamination. Tinam siguro kinahanglan i-explain og maayo kay masabtan raman gihapon because basic naman sad siya nga water contamination. Next is the groundwater quality. Groundwater quality refers to the state of water that is located beneath Earth's surface. Groundwater can gather in cracks, in subsurface rocks, and in between soil particles. Since many compounds can dissolve in water and others can be suspended in water, there is a potential for contamination with toxic compounds. This includes petroleum, hydrocarbons or oil, pesticides, minerals, and disease-causing or the pathogenic microorganism. That's all under the modification of the groundwater system and its effects. And sorry, medyo pagaw akong tingog kay pag Friday na ay event, and I hope you understand bisag pagaw akong tingog. Thank you.
Hydrothermal activity. Hydrothermal is a term referring to hot water. One manifestation of hydrothermal activity in areas of active or recently active volcanism is the discharge of gases, such as steam at vents known as ephemeras. Hot springs, also called a thermal spring or warm spring. In any spring in which the water temperature is higher than 37 degrees, the temperature of the human body. The heat of most hot springs comes from magma or cooling igneous rocks. The Morning Glory, one of the most colorful hot springs in Yellowstone National Park, Wyoming, is fringed with multicolored mats of heat-loving cyanobacteria and algal mats. Mudpat is another type of hot spring results when chemically altered rocks yield clays that bubble as hot water and steam rise through them. Bath, England. One of the many bathhouses in Bath, England that were built around hot springs shortly after the Roman conquest in AD 43. Hydraulic fracturing, pros and cons. Hydraulic fracturing has been around for many years and involves forcing fluids under high pressure into organic rich, impermeable rocks like shale or into already oil or gas producing rock formations to create fractures so that the oil or gas can more freely flow into the well. The risks are damage to the environment in the form of population to the atmosphere, groundwater supplies, as well as the release of greenhouse gases and health concerns resulting from the chemicals used in the fracking fluids, which are not always disclosed. The benefits are the oil and gas shales can go a long way toward continued energy independence, deliver and relatively inexpensive source of energy for the foreseeable future and provide a boost to national economics. The anatomy of a geyser. A. The eruption of a geyser starts when groundwater percolates down into a network of interconnected openings and is heated by the hot igneous rocks. The water near the bottom of the fracture system is under higher pressure than the water near the top and consequently must be heated to a higher temperature before it will boil. B. Any rise in the temperature of the water above its boiling point or a drop in pressure will cause the water to change to steam, which quickly pushes the water above it up and out of the ground, producing a geyser eruptions. This is the picture of anatomy of a geyser. Hot spring deposits in Yellowstone National Park, Wyoming. A. Minerva terrace form when calcium carbonate-rich hot springs water cold precipitating tavertine. B. Liberty Cup is a geyserite mound formed by numerous geyser eruption of silicon dioxide-rich hot spring water. This is a picture of hot spring deposits in Yellowstone National Park, Wyoming. Next, the geothermal energy is any energy produced from Earth's internal heat. In fact, the term geothermal comes from geo, earth, and thermal heat. Several forms of internal heat are known, such as hot, dry rocks, and magma. But so far, only hot water and steam are used in the production of geothermal energy. This is a picture of geothermal energy.
And that ends our discussion all about groundwater. We are the Group 12, and thank you so much for listening.